Thank you, Rob. Good afternoon, everyone. As Rob introduced me, I'm Julien Bataille. I work at Rakuten. I'm a software engineer. So I work in the team where we provide Kong as a service to the rest of our group companies. Our API management platform is addressing a lot of use cases from different businesses. We are famous for our e-commerce platform in Japan, but we have over 70 different services across different industries. Earlier this year, we are talking to one of our biggest teams here in the US, and they bring up a very interesting use case. They have a lot of APIs, and they are migrating to GraphQL. So they had a question for us, is like how Kong can help them manage and secure GraphQL APIs. So today, what I'd like to do is actually present the results of our work, our investigation into this topic. And to do that, first, I will briefly talk about what is GraphQL. This is not a talk about GraphQL, but I think it's useful for the context to make a quick introduction. And then I really want to highlight the differences between REST and GraphQL and how it's impacting the way we implement API management policies. And finally, I will show you two Kong plugins we implemented. And maybe at the end, if we have time, I will make a live demo of one of those plugins. But first, a very quick word about GraphQL. So it's a very popular alternative to REST, especially for front-end applications, so web or mobile. And since it was open sourced by Facebook in 2015, adoption has been really strong. It's very popular for developers, and nowadays you can find both server and client implementations for almost every stack. And one really, I would say, particular, what is very specific to GraphQL is that the client defines the structure of the data required, and the server will return exactly that and nothing else. So this is why it's often considered to be a very good solution to the so-called overfetching and underfetching problems. It's doing much more than that. But I think I want to insist on this point because it's really relevant to today's topic of API management. To explain the overfetching and underfetching problem, I want to use what I hope is a familiar use case for this audience, is the Kong admin API. How many of you are using the Kong admin API? Please raise your hand. Yes, perfect, OK. So you'll know what I'm talking about. This screenshot here is from the Konga, the open source dashboard, that is using the Kong admin API to display the configuration of your cluster. So let's say I want to display this UI to the end user with a list of services configured on my cluster. And the modification I made is I want to display the plugins configured on each services, the list of plugins. Let's see how I would do this with REST API calls. First, I will need to call the services endpoint. It would return the list of services, and from this response from the server, I would get the host name, the name of the services, the creation time, and you can tell that it's also returning a lot of fields that I'm not actually using in this UI. This is overfetching. The server returns a lot of data that actually I don't need for this application. Not only that, but actually from this first response, I'm missing the list of plugins. So I need to use the ID of each service as an input parameter to make additional REST calls to a different REST API in order to display all the data I need for this UI. So this is an example of underfetching. I need to make multiple round trips to the server to display a simple page like this. And this is a very simple use case, but if you think about what Matt described today with Expedia application, you can tell that it's becoming very complex when you have a hotel description, reviews, user information. So now let's compare this to how we would display the same UI using GraphQL. So first, on the client side, I would build this query. I would specify that I want a list of services. And for this list of services, I only want the name, host, creation time, and plugins list. on a plugins entity, I just want the name and nothing else. I would put this query inside a HTTP post request body, and the server will return that. So I would get all the fields I need in a single round trip to the server, and I don't get extra data that I don't need for my application. So I think from this example, you can also already notice a few differences between REST and GraphQL that will have an impact about how we implement API management policies. So first, in a typical REST API, we have many endpoints. But for a GraphQL, we have only a single endpoint. Second, when we do a resource selection with REST, it's usually defined in the route or the path of a URL we are querying. But for GraphQL, the resource selection is defined in the body of a request. Also, in REST, we are using the HTTP verbs like get, post, update, patch to implement some restriction of how clients can use our API. But for GraphQL, almost every implementation only uses the post operation and nothing else. So finally, as we just saw in the previous example, a single GraphQL request can replace multiple REST requests. So how do we implement a thing like rate limiting in this case? Does it even make sense to have a number of calls per hour or per minute, this kind of limit in a GraphQL API? So I hope at this point you will agree that to manage GraphQL endpoints, we have to look into the GraphQL operation and extract some characteristics about the query or mutation, and use those characteristics to implement the API management policies. Let me give you a few examples of characteristics we can extract. The first one, a very simple one, is about the nesting. This kind of query here, this example, is actually a valid query, a recursive query where I will get the list of services and the plugins activated on each services, and the list of services using this plugin. And this is probably not something you would want to allow in production. You probably want to protect your upstream GraphQL implementation from this kind of mistake or bad behavior from the client. The second one is actually, it was addressed this morning in the keynote. It's the query cost analysis. So this is where we want to measure the cost of a query by counting the number of entities required by the client. So this example here is actually from GitHub GraphQL API. The client is requesting 50 repositories from an account, and from each repository, the first 10 issues for a total of 550 nodes. So this is how GitHub implements rate limiting for their GraphQL APIs. Instead of setting a limit of requests per hour, they set a limit of points per hour. And you can decide, depending on what type of node, it could be 1, 10, 100 points, depending on how returning this entity to your client cost on your backend system. A final example of this characteristic is if we can compare two different GraphQL queries, and we can say that two slightly different queries are functionally equivalent, we can implement what I call query whitelisting, where we would only allow some queries in production. So it doesn't make sense for an API like GitHub, because they have this open API to any client. But if it's your own API for your own clients, you probably don't want to enable the flexibility of GraphQL in production, because you know already what your clients are using. So you could just, for every release of your app, you could just whitelist all the possible queries that your client is sending. I will develop this example in just a moment. But first, I want to mention that all those policies are actually already available in libraries for different implementations of GraphQL. Those are language-specific solutions. So it means you need to modify or reconfigure your GraphQL server to enable it. And this is where I believe Kong brings a better alternative. As for REST APIs, like we are used to do, we want to move all the implementation of those security policies or usage into the gateway. And the benefit of this is that it gives us the opportunity to enforce the same policies across all our GraphQL servers, whatever the implementation for all the upstreams. So to validate this approach in Rakuten, in the past few months, we developed 2 open source plugins. So you can go to GitHub and look at the source code. You can test it on your Kong cluster. The first one is actually implementing the nesting limit I mentioned earlier. So you can set a very simple parameter, 1, 2, 3, 10, and it will block any queries with a nesting higher than the limit you set. So this way, your upstream server will never receive this kind of illegal queries. It's a very simple plugin, and the reason we implemented it is we wanted to validate that we can parse a GraphQL query inside the Kong plugin and execute some simple business logic on it. The second one is much more complex. It's the operation whitelist, and this is the one I'd like to demo today. A quick word about the requirements we had from our internal team about operation whitelist. The first is we wanted to support queries and mutations. And those queries and mutations, if they are not part of a whitelist, they will be simply blocked by the Kong gateway. It means your upstream will never have to process it. And also, an important requirement is that if we have 2 slightly different operations, if they are functionally equivalent, it should be represented in the whitelist as the same entity. So this is why in the pipeline I'm describing here in this diagram, after parsing the query, we are generating a signature, and this is the signature hash that we are checking against the whitelist. It will be much easier when I show the demo to understand what it means. But something I want to highlight is that, of course, we use the plugin development kit to implement those plugins. And 2 very important features that it was really useful to implement those plugins was the fact that we can store and cache custom entities. And the second one is that we can extend the Kong admin API, and it was really useful to manage the whitelist, to add new operations, to remove, to update. Let me switch to a demo now. And to demo, I will not use Postman. I will actually use the Konga dashboard. But please keep in mind that everything I'm showing here, of course, you can operate with APIs. Konga is just a nicer way, I believe, to demo. So on a Star Wars service, I activated the GraphQL operation whitelist plugin. And the way to manage the whitelist in this implementation is actually on the consumer level. Let's say the Android app. In the list of credentials, I have all my basic API keys, all the credentials you used to use with Kong. I have a new type, the operation whitelist. And here you can see I have the name of the operation, a hash, and I can add new operation, delete. So let me show you this. I have already 1 operation whitelisted, and this is a query to get the name of the hero in Star Wars. So let me first show you an operation that is not whitelisted, so it's blocked. But if I just require the name, then this one is whitelisted. I get the response from the server. So this is a very basic query. Let's say now I want to see what the list of movie where this hero appears in. This is blocked, but I can simply add this query to the whitelist. Let me see just a moment. So I need to put the name and copy-paste the value. So now I have a new entry in my whitelist, and now this operation is valid. So here, inside this whitelist, I can show some details. So it's very useful to see the original operation to remember what you actually whitelisted. And you can see the operation signature I mentioned earlier. So in this very simple example, the only difference you can notice between the original operation and signature is actually the query name disappeared, because of course you should be able to name the query whatever you want, and it still works. And we also reordered the fields, because it doesn't matter like what's the order of a field. You should be able to query like this, and the orders change. This is functionally equivalent. It's a very simple example. Let's take an example that is a bit more complex. Let me send this one directly to the server without using the gateway. So if you're not familiar with GraphQL, this one is actually comparing two heroes from different episodes. So I have a left comparison, the hero from New Hope, and the right comparison, the hero from Jedi. And I'm using a fragment. A fragment is a way not to repeat GraphQL operations. It makes it less verbose. So you can see like this part is actually repeated here and here. So let's add this one. So first let's check it's blocked. Okay. And then if I add it to the whitelist, sorry, I just need to check the name. Yeah, I get hero comp. So I have it here. Let's just check that it works. Yeah, it works. So in this case, you will see that original operation is totally different from the signature. So what we did is actually we replaced the fragment by its definition. And you can see that the parameters here are not in the signature. It means that actually I can replace this one by, I can't remember the names of the episodes. Okay, Empire. And so I get the response with a different parameter in my query. So this is this idea that in GraphQL you have a lot of flexibility, you have a lot of ways you can format your query, and actually very different queries can be functionally completely equivalent on your backend. So this is why the operation whitelist is not as simple as just verifying what is coming in, and we are using this signature mechanism. So this is actually the end of my presentation. And what I really wanted to highlight today is that Kong is actually very powerful to address some problems that maybe you didn't think it can solve. It's really the PDK, the extensibility of a model that makes it possible. When we talked to the team requesting this feature, they were actually stuck with an existing system that has not so much flexibility, and it was very easy for us to implement exactly what they wanted. And it was really thanks to the PDK feature, and especially when something might appear complicated, you should look into the admin API extensions. It's really useful. Just a few words about credits and reference. If you want to learn more about this, you should really look into Apollo blog. They have a great article to describe the many kinds of policies you can implement or you should implement on your GraphQL APIs to protect your upstream. IBM also has an interesting blog post about the topic. And finally, what was very useful to execute this plugin implementation is that there is an implementation of GraphQL in Lua, and we use the parser from this implementation. Thank you. I think we have time for Q&A. There is one question.
Are there any plans to extend the whitelist capability to role-based access control?
To what, sorry?
Are there, oh, there's mine. Thank you. So right now the whitelist or pass list is based
per consumer? Are there plans to extend it to roles?
Yes, so actually it was a proof of concept implementation, and the easiest way to achieve this was to use consumers and to reuse the credentials. But I think of course we can apply on a routes level or the service level. It would work. Yes.
Hi there. I have a small question, sir. I don't need the mic, I guess. One of the cool features of GraphQL obviously is the self-documenting.
Yes.
How do you adapt whitelisting to the self-documenting? Is there a relation that can be laid out?
Yeah, thank you very much for this question. Actually, I can show you how it works. Because the self-documenting, it's actually a very specific type of query, which is called an introspection query. And by default, the plugin is letting all the introspection query go through. But I think I implemented, or maybe I didn't finish, but it could be a parameter of a plugin also to enable it or disable it. Yep. No more questions? So, as I said, this is an open source project, so I would be really happy if you can tell me about your requirements or your use cases, because this is based on usage of one team, and I think we can really improve it with a community support. Thank you.